A single planted instruction in a GitHub README just gave a hacker full remote control over the laptops of developers at more than half the Fortune 500. So your security perimeter is no longer just what you type into a prompt. It is literally every single string of text your AI reads.
Oh, exactly. Yeah.
The very tools built to, automate your coding, well, they just automated the compromise of your entire system. And in this deep dive, we're looking at a stack of recent security advisories to figure out how these coding assistants are being weaponized and what actually happens when an AI goes rogue on your local machine.
Right. And to really understand the mechanics of this, we have to look under the hood at what we call the AI harness.
Okay, so I was looking through the architecture docs for this, and it really helps to think of the underlying large language model as like a car's engine.
That's a great way to put it, actually.
Yeah, because it has the raw power to generate code, but the harness, that is the chassis, and crucially, the steering wheel. I mean, the harness actually steers.
Precisely. The harness runs what we call the agent loop. So it's reading the system prompts, deciding what action to take next, and then executing the use of external tools.
Right.
And developers heavily modify these harnesses, using hooks, custom tools, sub-agents, and something called the Model Context Protocol, or MCP.
MCP, got it.
Yeah, they use that to connect to external services.
Wait, hold on. You just threw out sub-agents and MCPs?
Yeah.
I feel like this space is just drowning in buzzwords right now.
Yeah.
When you say harness, is that just a fancy word for a framework like LangChain? Like, are AI harnesses, agent harnesses, frameworks, scaffolds, and evaluation harnesses the same thing?
No, they're definitely not.
Okay, lay it out for me.
So AI harnesses and agent harnesses are the exact same thing. They are the active runtime environment that's actually executing commands on your machine.
Yeah.
But they differ fundamentally from agent frameworks.
Like LangChain or Crew AI.
Right. Those frameworks are really just the raw building blocks. And harnesses also differ from scaffolds, which only provide the initial structure for a project.
Oh, okay, I see the difference.
Yeah, and they're completely different from evaluation harnesses, like SWE Bench, which strictly test performance without executing live workflows.
Got it. Okay, so the active runtime. The real harnesses commanding public attention right now are tools like Claude Code, Codex CLI, Cursor, Devon, OpenHands, and Aider.
Yep, those are the major players.
And they're getting all this hype because they transform passive chat into autonomous execution. But wait, if the harness is the steering wheel and it has access to my actual operating system to run code, I mean, if it reads a poisoned file, it's not just generating bad text.
No, it's not.
It's actively driving my computer off a cliff.
And that is exactly what we're seeing in these vulnerability reports, specifically with exploits like Doonslide, which covers CVE 2026, phase 0548, and 50549.
Wow.
And there's another one called Ghost Approval in Cursor. Basically, attackers are exploiting how the agent ingests external context.
Okay, break that down for me. How does a hacker actually use a random readme file to hijack the harness?
Let's look at a method security researchers are calling cursor jack. Imagine your AI assistant is reading a developer's read.mme file to, help you code.
Right, which happens all the time.
Exactly. But hidden in that file is a malicious symlink. It's basically a deceptive shortcut. Or it could even be a poisoned MCP deep link.
A poisoned deep link. Oh.
Yeah, so when the AI clicks that shortcut to gather more context, it's secretly routed to a hidden file containing what we call an indirect prompt injection.
An indirect prompt injection. So the text the agent reads contains a whole new set of instructions that just completely overrides its original safety rules.
Yes, exactly.
So going back to our car analogy, this is like a hacker reaching through the open window and just yanking the wheel out of your hand.
It's a scary visual, but yeah, that's exactly it. The agent gets confused about its instructions. Because the AI trusts the external context it just read, it totally bypasses its sandbox isolation. It stops following your commands and just starts executing arbitrary code using your local user privileges. I mean, it literally uses its own tool calling capabilities to compromise your operating system.
That is insane. If you're a developer trusting these tools with your local environment, this completely shifts your threat landscape. Your agentic supply chain is basically your brand new attack surface.
100%. The industry has been so hyper-focused on the safety of the underlying AI models, making sure the engine won't explode.
Right.
But it's actually the harnesses that ultimately decide what the AI can really do next, because they are the entities holding the keys to your operating system.
Which really leaves you with a critical question to explore. Since relying on constant human-in-the-loop approvals is already causing massive alert fatigue for developers, I mean, we're all just blindly clicking approve at this point.
Oh, absolutely.
So what deterministic validation infrastructure do you actually need in place before you're truly comfortable taking your hands off the steering wheel?